And what Lex identifier does is that here. It allocates a string, then it saves the current column, so we know where the column was when we call Lex identifier, and then while we did not encounter a new line or a comma or a brace or parens or a semicolon or braces or a dot or a star, then we want to append this. Here is the append operator, this tilde, here is the append operator indeed. Then we want to append the first character of our source code to the string. We increase the position of the column in tandem, and we take the slice of we slice one character off the front in our source string, so on the next iteration our cursor will have advanced. Okay. Well, we would actually not have to do this. We could slice the original source because we updated the position. Yeah, probably we should do that. Pause to this. Yeah. Then we get the string ID of this string we have just created, and we return a token with the token type identifier, the string ID, the line, and the column number we have saved up here. Lex integer literal is pretty much the same. If any of those separating token here is encountered, it breaks, and if it is not, it takes the source, it takes the first character of the source, which is an integer, subtracts the integer value of the character 0 from this. So if we have encountered a 0, we will get 0. If we have encountered a 9, we will get 9. If we have encountered an A, we will get minus 7, I think, something like that. And that value, which should be in the range of 0 to 9, if we really had a number here, let us actually assert this. That it is a number. And it's pretty easy. We can simply say assert that whatever this is greater than or greater equals 0 and that it is smaller than or equal to 9. Thereby we can basically assert that this is a valid identifier. Okay. So this will be in the range of 0 to 9, and this is multiplied with the current column we are in minus the column we started to the power of 10. And this basically multiplies it with 1 if we are in the column we started, multiplies it with 10 if we are 1 away from the column we started, and so on. So this will make sure that we have the right value. We could assert in here that the value cannot be greater than, no, that would actually make no sense. That the value cannot be greater than unit max, because it will wrap around before this happens, and yeah, we cannot do any meaningful easy check here. So then we advance position column and set the new source to this. We can simply copy this line and paste it here, and we see that there's a lot of code duplication. This check if we have met character which terminates the literal is duplicated. This advancing the position and the column and slicing the source in new is duplicated, and perhaps even more. So this is definitely not the thing we want to do, because we have much code duplication. Lexing the string. This works like this. We first check that we were indeed called at a place where there's a quote. We advance our cursor. We slice one of our source stack. Then we check that we haven't reached another quote that terminates the literal. We advance. We add whatever there were to the source, to the string. We advance the position. We advance the column. We slice again one token off, and when we encounter this closing quote, then we will advance the position, advance the column, and slice one off, because we need to get past the closing quote. Otherwise we would lex the stuff that comes behind it as a string literal too. And then we get the string ID and return a string literal with a string ID, line and column. This is the same thing we did in the identifier lexing here. And yeah, now it is time to show what this getStringID does. GetStringID uses a feature of D, associative arrays. Associative arrays get defined like this. They have a value type and a key type, and you can assign values to keys basically. This is a key value storage. And the key in this case is a string, and the value is just an increasing integer. So this is a hash table of strings. And with that we can easily compare strings by taking a hash of them. And we can a string we have already encountered will have some number, and a string, and if we have not encountered the string yet, we insert it with the current running index +1, and so we can keep track of identifiers we have already seen without having extra logic in the Lexer for this, because we just when we see an identifier or string literal, we just point to this table and say get something out of this table, and if it is not in there, the string, then put it in, and if it is in there, just get the ID. So we can basically, we don't have to do checking if the identifier was seen or not or anything else. It is just done by the string interning mechanism. String interning is this thing where you just have one instance of each individual string, and if you see one string twice, then you just make it point to the string that you already know. What's my intention issue here? So I just no, I don't. Do I? No, I don't. This is if. Yeah, I do. I have to indent all of this by 1. No. This is better, yes? Yes. Well, now that I have gone through the Lexer, please tell me what you think of this. Oh, I can show that this really does work. This is the input string, and those are the tokens.